Welcome to our deep learning based automated diagnosis of infectious skin lesions project. In this project, we have used convolutional neural network to classify 11 classes of skin lesions caused by microorganisms like virus, bacteria, and fungi. The dataset we have used, the classes were imbalanced and images were of different resolution. So we had to go through some pre-processing steps first. Convolutional neural network works greatly on grid type data like images. Images are made of pixels and placement of pixels contains spatial information which can be retained by CNN. But the problem with CNN is when we are making a CNN model from scratch and working with a dataset that contains thousands of images, to train the model often becomes tedious task and requires huge amount of computational resources. To encounter this problem, transfer learning approaches comes to rescue. To obtain our objective, we have worked on pre-trained model MobileNet V2. CNN works like the visual cortex of our brain. Initial layers tries to find the primitive features and later layers makes more complex features using those primitive features. So what we did, we froze some initial layers of the MobileNet V2 and trained the later layers in convolutional layer part. Then we have made our custom fully connected layer and trained the model with our own dataset. We have tried to make some changes in the hyperparameters to see how our model is performing. To reduce overfitting, we have tried dropouts, regularizations, learning rate scheduler, and early stopping concepts. We have tried three approaches, and from first approach, if we see the training and validation accuracy graph, after 25 epochs, the accuracy reached nearly 85%, and the overfitting is much reduced. We have tried two other approaches by changing the hyperparameters, and we have seen in the approaches 2 it took nearly 35 epochs but underfitting occurred. And in the approach 3, we have seen that it took nearly 80 epochs but the accuracy was more or less uh, like the approach 1 and approach 2. So from the trade-off between accuracy and training time, we can see our model 1 or approach 1 performed better. And finally, we have checked our model's performance with some images that we have downloaded from the Google and checked if our model can identify them correctly or not. We can see that most of our images were identified correctly by our model. Thank you.